Introduction. What is the resultant force? When an object is subject to several forces, the resultant force is the force that alone produces the same acceleration as all those forces. The reason why the resultant force is useful is that it allows us to think about several forces as though they were single force. This means that to determine the effect that several forces have on an object, we only need to determine the effect that a single force has. Description. First, two forces acting in the same direction. Let's start with the simple case in which an object is subject to two forces that act in the same direction. The resultant force is in the same direction as two forces and has the magnitude equal to the sum of two magnitudes, which is 3 Newton plus 4 Newton equal to 7 Newton. Next, two forces acting in opposite direction. If the two forces are equal in magnitude, the resultant force will be zero because two opposite forces cancel each other out. On the other hand, if the two forces are not equal in magnitude, the resultant force will be in the same direction as the force with the larger magnitude, and the magnitude equal to the difference between the magnitude of the two forces, which is 5 Newton minus 3 Newton equal to 2 Newton. Lastly is more than two forces parallel to one another. To find the resultant force in this case, we first sum up all the forces that go in one direction, and then all the forces that go in the other direction, which is 5 Newton at 6 Newton equal to 11 Newton, 3 Newton at 4 Newton equal to 7 Newton. At this point, we have two forces that are in opposite direction, which is in case that we already know how to solve. The resultant force has the same direction as the force with the larger magnitude, which is the 11 Newton force, and its magnitude is equal to the difference between the two magnitudes, which is 11 Newton minus 7 Newton equal to 4 Newton.
1, 2, 3.
Finally, after a few more whistles in the Persian Ocean, we managed to get the system from Captain Barbarossa.
So, where do we need to go after this, Captain? Do we have to complete another task from Captain Jack Sparrow?
We already complete all the tasks. Now, we need to return to Atlantic Ocean to give this amulet to Captain Sparrow.
Captain, we have a problem. The ship suddenly stopped sailing, and we don't know why it's happened.
What? Let me check first. This is weird. This has never happened before. Are you sure the anchor wasn't away to the sea?
Yes, sir. I have made sure about it through my man.
If yes, why we got stuck in the middle of the ocean?
I'm very sorry, sir, but I don't have an answer for the question.
It's okay. I know we can find out the cause of this problem. Margaret, can you find out the cause of this problem?
Sure, I can.
There once was a ship that put to sea. The name of the ship was a Billy of Tea. The winds blew up her bow, up down, oh below my bully boys blow. Soon may the wellerman come to bring us sugar and tea and rum. One day when the tide is done, we'll take our leave and go.
Your ship is stuck. To follow this step. Firstly, you have to bring down two boats with two different forces into the sea. A boat has a force of 15,000 Newton at angle 30 degree, and another boat has a force of 20,000 Newton at 50 degree. Okay, so first we have to apply triangle force. Okay, next we have to use the laws of sines and cosines to solve for the resultant. To do this, you need to determine the angle beta in the force triangle first. With the help of the force parallelogram shown below, you can determine the value of beta, knowing that the opposite corners of a parallelogram have equal angles. With beta known, you can use the law of cosines given as summation force equal to 0. To solve for the magnitude of the resultant force, R equal to square root of 15 square plus 20,000 square minus 2 times 15,000 times 20,000 cos 100, and the answer is 27,003.5 Newton. Then use the law of sines to solve for angle alpha. R divided by sin beta equal to B divided by sin alpha. So sin alpha equal to 20,000 divided by 27,003.5 sin 100. Alpha will get 46.8 degree. Therefore, the direction of the resultant force is 16.8 degree below the horizontal reference line. Then you can move your ship by boat using 2 boats to your destination. Good luck!
Yes. Guys, can we start the mission now?
Aye, Captain.